Hello, everybody. Today we want to talk about chapter 2. We want to talk about NumPy. So if you have Anaconda, then you can install NumPy by going to your Anaconda prompt. So this is Anaconda prompt. Then you open up this, and then just all you have to say is Conda install NumPy and hit enter, and then it automatically installs the NumPy if you don't have it already. So I do have it already. I mean, it's doing that again, as you can see on my monitor, but you can always do that. Okay, after doing that, and it's gonna take like a couple of minutes for sure, but then we wanna import NumPy as NP. So just type this out, import NumPy as NP, and then we are gonna work with it. So here we use NumPy to create arrays. Yes. So for example, to obtain an array off of a list. So the following package would be updated. We are going to click on yes, for example, and then okay. To obtain an array off of a list, so we're gonna run this, and then I'm gonna have this my list, and then take a look at my list. Is like 4 numbers: 10, -2, 13, and 0. And then so now we are done, and it's all done. I can just close this window, but all I have to do is to just type in Anaconda prompt. I had to type exactly this, conda install NumPy, and then here I just wrote like import NumPy as NP. Okay, let's start working with the NumPy. So I'm gonna say np.array and then the name of the list that I have, which is my list. If I do that, I'm gonna get this out5. Look at out5 is array of 10, -2, 13, and 0. It's an array of 1 row and 4 columns. And if I ask what's the type of this array, type of my list is definitely a list. But if I take a look at, if you want to create an array off of a list, so I can name it, for example, arr, which is np.array in my list. And then I can take a look at arr, and then I can check the type of arr, which is NumPy ND array. So that's a new type of things. If we want to transform a nested list to a NumPy array, we'll get a matrix. So this is a way to get a matrix. Look at this list 2. Yeah. List 2 is a nested list. Is a list which includes 4 lists. Each list has 3 items. Then if I get R2, then, and I print R2, or I just take a look at R2, it's going to be a matrix of 4 rows and 3 columns. A nested list is a list of lists. We already know that. You can extract like elements from this. For example, list 2 in brackets 1 is going to give you this: 10, 12, 13. And then you can, out of that, extract, for example, elements index 2, which is 13. So we had this already. Or if I want to call -8, I'm gonna say list 2, then it's gonna be third list index number 3, and then item index 0. So this one gives you -8. So R2 is a matrix. You run this, you're gonna again see NumPy.ndArray. Okay, now we can find the dimension of a matrix with shape. Remember, when you use shape, you do not put parentheses. Shape is 4 by 3. What does it mean, 4 by 3? It means we have 4 rows and 3 columns, as you can see it right here. Yeah, we can transpose a matrix easily. We just transpose that matrix, and then there are some built-in NumPy functions that we want to talk about them. So what does transform mean? Transform means that all the rows become columns, all the columns become rows. Okay, with some built-in NumPy functions. Arrange works as np.arrange start stop step, which is step by default is 1. Start is inclusive, start stop is exclusive. So we had this arrange before. Arrange, and then we had, for example, from 5 to 9. So it's so you remember range function that we had before, yes? For example, if you use list range 5 to 9, you're going to get 5, 6, 7, 8. So the left one is inclusive as always, right one is exclusive. I mean, 5 is inclusive and then 9 is exclusive. Now, we can have like NP, but rather than range, we are going to have arrange. np.arrange 5 and 9. You do that, you get array of 5, 6, 7, 8. So rather than list of 5, 6, 7, 8, you'll get array of 5, 6, 7, 8. And then, for example, you can have range start, stop, and step. So it's going to be this one just from 3 to 3 and 6. But if you do 10, it's going to be 3, 6, and 9. Yeah. Question. Provide an array of all two-digit odd numbers. All two-digit odd numbers. If you want that, you got to do this. From 11 to 100 and step of 2. That gives you all two-digit odd numbers. You can have an array of 5 zeros. For that, for zeros and ones, we have something specific, np.zeros. That's going to give you an array of 5 zeros. Just remember that, as you can see, 0 dot, the 0 point means it's a float, it's not an integer. Okay, let's review a little bit of materials beforehand, and then we're going to have again new stuff. A tuple is a collection of objects which ordered and immutable. Tuples are sequences, just like lists. The differences between tuples and lists are the tuples cannot be changed, unlike lists, and tuples use parentheses rather than brackets. Whereas lists are use square brackets. So here we have a tuple, yes? You do this, type of this is going to be a tuple. And then if you pass in a tuple, you'll get a matrix as well. So this one, you're going to get a matrix, which is vector as a matter of fact, but it doesn't matter. We can call it matrix as well. And then, or you can get this one, np.array, and then we have two tuples, 4, 5, 8, and then I guess we have one extra set of parentheses here. 5, oh, okay, sorry. That was necessary. Okay, yeah, now we are good. So we have the first parenthesis for NP array, yeah. The second one is to pass two tuples, to pass a tuple inside, and then tuple includes two tuples. So the first parenthesis is for array. The second one is to include tuples, and then the third one is to include the first tuple, and then here you have the second tuple. You run that, you get a 2 rows and 3 columns. Another example, NP zeros 2 and 3. You get a matrix of 2 rows and 3 columns. An array of ones. You can have that NP ones. So here we get 3 ones. Here we get 3 rows and 4 columns of ones. You can add a scalar to a matrix. For example, you can add number 50 to them. So it's going to be a matrix of 2 by 3, and then you of ones, and then you add number 50. Or multiply or divide by a number. We cannot do with lists, but with arrays we can do that. For example, np.ones of 3 multiplied by 20, you get this. Divided by 20, you get this. We can create a linearly spaced arrays. So it's np.linspace, and then stop number of times that we have. So for example, this one, np.linspace. So 10, 15, 20, 25, 30. Just remember that this was an exception, that stop is inclusive when you have linear space. A big exception, stop is inclusive. Usually this is not the case in Python, but np.linspace 10 to 20. So it starts always with the stop, with start, and ends with stop, and then how many then we have this like steps, yeah. Okay. Next example, how to check the number of items. So this 4 is like how many numbers we are gonna have inside this linearly space. So when it's 4, it's gonna be 10, then 16.67, and then 23.3, and then 30. So number of numbers that we are going to have in linearly spaced is identified here. Okay, how to check the number of items in a list or in an array. So we had this again before. len gives you a length of a list. For example, my list was whatever it was, 10, -2, 13, 0. Length, you just len, and you see the length. len np1s of 3 is going to give you 3. np.linspace 1035. For that, you're going to get 5. yeah, because you have 5 numbers then. List 2, it's a nested list. You have a list of 4 lists. So if you do that and you check the length of that, it's going to be only 4 because you have 4 items inside, 4 objects inside, 4 lists. NP1 of 2 by 3, that's going to be this, and length of that is, so here we are going to have just 2. Yeah, one is this one, the second one is this one. Identity matrix. Identity matrix is the, on the main diagonal you have ones, all other elements are going to be zeros. This is identity matrix of by 3 rows, 3 columns. You just write np.i3. np.i4 gives you identity matrix with 4 rows and 4 columns. Creating a random number, creating random numbers, that's very also important, very practical. np.random. np.random.rand gives an array of n numbers from the uniform distribution between 0 and 1. Yeah, so if, and this n inside gives you how many, tells you how many numbers you want to have. So here you're going to have 3 numbers, random numbers between 0 and 1. If you want to get a matrix of random numbers, do not pass a tuple, just separate them by comma. np.random.rand, for example, 4 and 2. You get 4 rows and 2 columns. All of them are random numbers between 0 and 1 from uniform distribution. If you prefer the standard normal distribution, use np.random.randn, and then inside it is going to be the number that you want. So, for example, np.random.randn3 gives you 3 numbers from normal distribution with mean 0, standard deviation of 1. np.random.randn 4 and 2. It gives you a matrix of 4 rows and 2 columns, all of them from random standard normal distribution. If you want to determine the mean and variance of the normal distribution, use np.random. Rather than randn, just use normal, and then inside parentheses you're going to have mean, variance, and size. Mean, variance, size. Yeah. Now if you, here you want a matrix of random numbers from normal distribution, for example, with mean of 2 and variance of, with mean of 3 and variance of 2, you want a matrix of 5 by 4. You pass the dimension of 5 by 4 in tuple. So you get 5 rows and 4 columns. All of them are from normal distribution with mean 3 and variance of 2. If you want a random integer number, you can between 2 numbers, you can use np.random.rand rand int, low high size, and high is exclusive as always. So for example, 10 to 20, it's going to create an integer number between 10 to 20. 10 is inclusive, 20 is exclusive. So you do it one more times, you get like different numbers. Each time you might get different number. Yeah. Okay. np.random.randint 10 and 20 and then 3. It gives you 3 numbers, 3 random numbers. There can be a repetition. Yes, of course it can be, because they're random. Question: what's the output for np.random.randint 10 and 11? That's a very good question. Just think about it for a second. So it's going to be 10. If you run this, it's going to be 10. Why? Because 10 is inclusive and 11 is exclusive. So the only number is going to be 10. So necessarily the answer to this is going to be 10. Okay, how if we are working on a project and want to produce the same random number? So let's say that we have a project, we all want to get the same random number. Is there any way that we can do that? Yes, we can use a code called seed. Use np.random.seed, and then inside parentheses, there's going to be a number. To avoid making mistakes, select both rows and then run them. So here I'm selecting both, run them, and then you get this. So if you do the same, you're going to get the same numbers as I got. In all other examples, when you're running these codes, you might get another number. Here you run this, you're going to get the same numbers. Number 8 does not have any particular meaning. It just gives all of us the same results. Yeah. So, but if you run it without this seed number, you're gonna get different numbers. You run it with that, you get the same numbers. 0.8734 is the first number, 0.968 second number, so on and so forth. Okay, a few attributes of arrays. Consider these two matrices. For example, R1 is NP, a range of 0 to 9. So 9 is exclusive, so it's going to be 0, 1, 2, 3 to 8, and then np.random.rand integer from 0 to 100, 10 integer we want, okay? 0 inclusive, 100 exclusive. You do that, for example, we get this number, this matrix. We can first of all reshape matrices. For example, underscore reshaped equals reshape 3 by 3. First matrix that had 9 elements, we want to just, rather than having it 1 by 9, we want to make it 3 by 3, and we want to give it a name, and the name is reshape. You do that, you get this. So 0, 1, 2, 3, 3, 4, 5, and 6, 7, 8. So we just reshaped that matrix. We can also reshape the second matrix. So it was this one, 10 numbers, and I want to reshape that. I can do this. Yeah, we are gonna get 2 rows and 5 columns. The first number is number of rows. Second one is number of columns, as you can guess. What's the output for this? R2.reshape 3 by 3. So R2 has 10 elements. Now, if you want to reshape that in 3 by 3, what do you guess you're going to get? So you're going to get an error. It's going to say, oh, cannot reshape array of size 10 into shape 3 by 3. Yeah, and it makes sense. Okay, moving on. Max, mean, argmax, argmin. We're gonna so let's take a look at this matrix R2 one more time. And then here I want to guess the output for this. R2.max, it's going to give you the maximum number, 85. R2.min, it's going to give you the minimum number, 9. Argmax and argmin give the index location of max and min. So, for example, 85 is where? Is index 0, index 1, index 2. So arg r2.argmax is going to be 2. How about minimum, which was 9? It was index 0, 1, 2, 3, 4, 5, 6, 7, 8. It's going to be index 8. You run this, you're going to get 8. So it gives you the location of that maximum or minimum. If you want to check the type of elements inside an array, so you don't want to check the type of the array itself, you know that's an array. You want to check the elements inside, you can do this array.dtype. And as you can see, it's integer 32. Important note if you make the following mistake. If you put parentheses, what's going to happen? Then you're going to get an error. NumPy.dtype object is not callable. So when you're putting the parentheses, they say you're calling this object, and it's non-callable. The action occurs when you attempt to call an object with parentheses, which is not a function. Another example, for example, assume x has a fixed value 5, and then you say x parentheses, you call it. You're going to get an error. Integer object is not callable. Okay, indexing and selection. We're going to talk about indexing and selection. So let's work on indexing and selection. By indexing, we grab a single element from either one-dimension arrays or two-dimension. By selection, we grab a slice or a chunk from arrays. Okay. For example, let's take a look at this this one. Here we have array of all the even numbers from 2 to 18. And then when we say R2, it's going to be taking the index 2, which is number 6. Index 0, index 1, index 2. For selection, first index is inclusive, the second is exclusive as always. So this one is going to include array, but from it includes in the indices 3, 4, 5. So it's going to be 8, 10, 12. Output for this one from 0 to 3, so it's going to be index 1 in index 0, index 1 in index 2. 3 is exclusive, so it's going to be 2, 4, 6. You can equivalently use this one, so you don't have to put 0 for the first one. Similarly, if you want to go all the way to the end, we leave the second number empty, so this one from 4 to the very end, you can do that. You can add a number to all elements of an array. For example, this one. It doesn't matter. It does not change the original array. So if you take a look at R, still we have this one. If you want to save the result, you have to create a new one. For example, like here, new array is array plus 100. Take a look at array is as before. New array is 100 more than that. Or you can override and modify the original array. How do we overwrite it? It's like R equals R times 2. I did it twice. So let me run R again and again. And then R is R twice, and then take a look at that. Now if I run this line one more time, let's see what happens. I ran it 2 more times, but you can see now numbers are even multiplied by another 2. Broadcasting. Imagine NP equals array R equals numbers between 0 to 8. Now, slice of this array is, for example, from 0 to 5, 0 inclusive, 5 exclusive. Take a look at that. Now, we say that slice of array, this one equals 20. Take a look at slice of array, it's going to be 5 20s. Now, take a look at the array itself. Now, all the 5 elements are changed. Although we didn't do anything on air, we just made the change on slice of array, but air itself is also changed. Okay, you see the problem? Not only slice of array changed, but also air changed. This is unlike R. In R, we don't have this problem. To solve this problem, we use dot copy. So here we are going to have air equals np.range 0 to 9. Then take a look at air. Slice of array is air between 0 to 5 dot copy. Now take a look at that, make it equal to 20. Slice of array, take a look at array is still as before. So if you want to just change that part, you gotta do just use slice of array, use dot copy. Indexing and selection on two-dimensional array or matrix is like very similar to before lists. For example, we have array of np.arrange 0 to 9, 0 inclusive, 9 exclusive. Reshape it by 3 by 3. Take a look at that. First row 0 1 2, second row 3 4 5, third row 6 7 8. Now selecting the second row is going to be R1. Grabbing the element 3, second row, first column is going to be R1 and then element 0. Or you can say array 1 and 0. So this means row index 1, column index 0. What's the output for this guy? So before running this, let's take a guess. So it's going to be row index 2. So this is row 0, row 1, row 2, and then column index 1. So this one, 7 is going to be the answer. If we want to slice a chunk of a matrix, for example, rows 2 and 3, and columns 2 and 3, we do this. So columns 2 and 3, we do this array. So this is just a chunk. Only the third row, we do this R2 and 0. That gives you third row, or this one, just 2. So the first element talks about rows, second element talks about columns. What's the output for this question? Array 1 0, it's going to be second row, 0 1 2 3 4 5. Oops, it's going to be second, row index 1 and row index 2. This one, all rows, column index 1. It says 147, but it's printed as a row. This one, all rows, columns 1 and 2. Indices 1 and 2. Conditional selection. Let's say we have a NP range between 0 to 9, 0 to 10, 10 exclusive. Now we want array of numbers greater than 5. You do that, you get an array of booleans. So it's going to take value false for all the numbers that do not satisfy this condition. So it's going to be false, 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 because 5 is not greater than false, and then for 6, 7, 8, 9 it's going to be true. So we have 4 truths. Let's save it in an array, array 2, save it, take a look at array 2, take a look at array, or this one, we look at the same result with this, array r is greater than 5. Let's give you 6, 7, 8, 9. So you do the condition inside brackets. What's the output for array r is less than or equal 3? So it's going to be just this one. 1, 2, 3. NumPy operations. Let's have an array of all the numbers from 0 to 10. And if you want to get the square of all numbers, you can just put this square. You can multiply them by a number or add them by a number. Also, if we have two arrays of the same shape, we can do this. So this one has the same shape, different numbers. So this one was array between 0 to 10, array 2 is between 10 to 20, array 2 minus array 1 is going to be this, all tens. What's the output for array plus 2 times array 2? So you multiply array 2 by 2, then add it by array 1. This one. Now, if we divide by 0 or infinity, we don't get an error, we'll get a warning. Yeah. Here, this guy is not an error, it's a warning. Runtime warning. Divide by 0 encountered in true underscore dividends. So it says that at some point we divided by 0 for the very first number. You can do this array by array, divide it. Again, why this one is NaN? Because 0 by 0 is not a number. It's going to be NaN. Square root, np dot square root of array. It gives you square root of all elements in the array. Natural log, np dot log array. Some other functions. Sum, we have that sum just gives the sum of all the elements inside the array. Mean, it gives you the mean. It's going to give you the average of elements of that array. The sum of elements of array, average of elements of array, sum of rows or columns. That's a new one. So we have this array. It's 3 by 5, 3 rows, 5 columns. Take a look at the shape, 3 by 5. Give me the sum across the rows and sum of the values in the columns. Yeah. So it's going to be the very first column 0, 5, 10. It's going to be 15. Second column 1, 6, 11. So it's going to be 18 and then 21, so on and so forth. If you want sum of the values in the column, you do this. Array.sum axis equals 0. Give me the sum across the column and you get this 10, 35, 60. You add these all of them together, you get 10. You add all of these stuff together, you get 35. And all of these together, you get 60. Okay, that's it for this section, this chapter.